Okay, I'll make it really simple for you to understand. A radical is something that has an unpaired electron. Like, for example, let's compare two things. This is element A and this is element B. Element A is a radical because it has an unpaired electron, as you can see. Element B is not a radical on the other hand because all the electrons occur in pairs. Now, A is highly unstable and extremely reactive. Why? Because it wants this electron to pair up with another to satisfy the octet rule. Now stay focused. We're about to discuss two types of fission reactions, homolytic fission and heterolytic fission. Let's start with heterolytic. Hetero means different and lytic means to split apart. So we can infer that there are going to be different elements that will split apart. I'll give you an example. This is a molecule. A is bonded to B via a covalent bond. Now, I want you to assume that A is more electronegative than B. Electronegativity means the tendency to acquire electrons. So when an element is more electronegative, it attracts the electron with more intensity. Element A in this case is more electronegative than B. So when the bond breaks, these two electrons that were shared in this bond will be acquired by A. Why? Because it's a cruel world we're living in. So element A, being more electronegative, will take both of the electrons that were previously shared in the bond. That's how A gets a negative charge as it gains electrons, and B gets a positive charge as it lets A take its electron as well. Example, hydrobromic acid. Bromine is more electronegative than hydrogen. So when the bond breaks, the electrons get attracted by bromine and it gets a negative charge. The hydrogen atom gets a positive. Now, homolytic fission, where equality is practiced. Homo means same, and again, lytic means to split apart. Example, A is bonded to another A. Both are equally electronegative, meaning that none of them attracts electrons more than the other. When the bond between them breaks, the electrons are distributed equally. For instance, bromine molecule. When the ultraviolet radiation strikes with this bond, it will split, releasing the electrons. One electron will go to this bromine atom and the other electron to that one. Now, something is wrong. I want you to notice it. These, ladies and gentlemen, are two radicals that have just formed. Just look at them. They have one unpaired electron, and this makes them highly unstable and therefore highly reactive. Why? Because it just wants one electron to satisfy the octet rule, which is that an element has to have 8 electrons in its valence shell to be stable. This bromine atom has 7, so just imagine how crazy it would be going to acquire one electron to become stable. Now, you guys ready to jump into free radical reactions? It's easy, believe me, once you've understood the concepts that we've just discussed. Free radical reaction comprises 3 steps: initiation, propagation, and termination. When you generate a radical, it's an initiation reaction because, duh, you need a radical to exist in order for the free radical reaction to continue. For instance, this chlorine molecule, which is a neutral molecule, breaks down into 2 chlorine radicals. Now that we have a radical generated, the free radical reaction has been initiated. Coming on to the next one. The propagation is when one radical is forming and one radical is becoming neutral. For example, when methane reacts with one of those chlorine radicals, a methane radical and HCl are formed. Notice that we have one radical on the reactant side and another forming on the product side. That's why we refer to this step as propagation, as the molecule that has just formed can react with another neutral molecule to generate another radical, and this cycle keeps going until termination occurs. In this step, we terminate or put an end to free radicals and turn them into a neutral molecule. The two methane radicals can react to form a neutral ethane molecule. Two chlorine radicals can react to form a neutral chlorine molecule. One methane and one chlorine radical can react to form a neutral methyl chloride molecule. The goal is to put an end to the free radicals as they're highly unstable and keep creating disturbances in our already disturbed environment. Hope this video helped you. Don't forget to subscribe to my channel and hit the like button. Thanks for watching.